Okay, yeah. So we have this question, um, which reads: a case control study was conducted by a way of file review to measure the association of liver cirrhosis to a history of chloroform medication. Okay, so we have this question. We have the people that were exposed or treated with chloroform, which is chloroform exposure. We have the liver cirrhosis group and the control group, and we have no chloroform exposure. So we have people that were exposed to chloroform and people that were not exposed to chloroform. Then we have people who developed the condition, which is liver cirrhosis, and people without liver cirrhosis. Okay, so these are the numbers of people, or this is the exposure that we want to study today. So the question says, what is the likelihood of developing liver cirrhosis if a patient was exposed to chloroform? Okay. Then the other question says, what is the likelihood of developing liver cirrhosis if a patient was not exposed to chloroform? Okay, so this is the question that we have, and it was 3 marks. All these two questions, all of them, they carried 2 marks. Okay, so yeah. So this question, when they ask you what is the likelihood of developing liver cirrhosis if a patient was exposed to chloroform, what they are asking is the odds, okay, or the chances of developing the disease if you are exposed. Okay, if you are exposed, between the people who have the disease and those people who do not have the disease, what is the chances of you developing the disease if you are exposed to a risk factor? Okay, and they say, what is the likelihood of developing liver cirrhosis if a patient was not exposed to the risk factor? Again, they want you to find the likelihood or the chances of developing the disease if you are not exposed um, to the risk factor. Okay, so we are still looking at the association between the risk factor and exposure. Okay, so from this table that we have people that were exposed to chloroform and people that were not exposed to chloroform. Then we have the people with the disease. These are called cases in other terms. So these are cases and the controls. Okay, so that is now the group of people that we have. So among people who were exposed to chloroform, how many had the condition and how many did not have the condition? Hello? So when you look at this table, the first you have liver cirrhosis, and for liver cirrhosis we have 400 and 200. All these people were exposed and they have the condition. We also have the control, and we have 150. So all these people are exposed. Then we also have this side. For those people that were not exposed, we have 50 and 100. These were sick or are the cases, and we have 100 and 200, which are the cases. So now, what is the formula for calculating the odd? So this what we are calculating here is the odd. So what is the formula for calculating the odd? So when they say the likelihood, they want you to calculate the what? The odd. So we want to look at the formula for calculating the odds. Okay. So the formula for calculating the odds is given as Number of cases divided by number of control. Number of cases, those people who are sick, and also the control, the people who are not sick. Okay, that is the odd. So when we look at this table that we have, the first question says, what is the likelihood of developing liver cirrhosis if a person was exposed to chloroform? So what we need to know the cases for people who were exposed to chloroform, and also the number of controls for people who were exposed. So first, what we need to do, we have seen this table, it has too many figures. It has these numbers 400 and 200, which is the same. So we need to first construct a 2 by 2 table. Okay, a 2 by 2 table. So let's construct a 2 by 2 table. Where is this one? So a table should look like this. Okay, these people are exposed, these people are not exposed, unexposed to chloroform. Then we have cases, these are cases, and control. So for people who were exposed, how many are the cases? So when you look at these, there are 600. Yeah. So when you look at these people exposed, these people are the cases. They have the disease. So 200 plus 400, that gives us a 600. Then you look at the controls. How many people had were the control? We have 150 plus 100 plus 150. That is 150. So you have 150 for the control. Okay. Then you come to those who are not exposed. How many people, how many cases do we have?
150.
150. Okay. Then how many controls do we have?
300.
300. Yes. Yeah, 300. Then the question says, what is the likelihood of developing liver cirrhosis if a patient was exposed? So we say the likelihood, which is the odd, is calculated as what? Cases over what? Over control, right? So for people who are exposed, what are the cases? How many cases do we have?
600.
600. Divided by the control, 150, right?
150.
Yeah, so 600 divided by 150,
4.
4. Okay. So this means that if you are exposed, you are 4 times likely to have the disease. Okay. If you are exposed, you are 4 times likely to have the disease. Then you can now look at what is the likelihood of developing liver cirrhosis if a patient was not exposed to chloroform. So this one also will say, for those who are not exposed, how many cases do we have? We use the same formula,
150.
150. Okay. divide by how many control do we have?
300.
300, yes. 150 divided by 300. 150 divided by 300. What is the answer?
0.5.
Yeah, 0.5, right?
Yes.
Yeah, so if you are not exposed, the likelihood of developing liver cirrhosis was 0.5 for these people who are not exposed. So that was the likelihood. Yeah. Any question on this one?
So, sir, these figures, the 4 and 0.5, are they in percentages or it's just 0.5?
It's just 0.5.
Noted.
Yeah, these are the chances. These are the chances.
Sir, I have a question.
Yes.
These figures of the exposed and the unexposed, why are they in two parts?
Why are they in two parts? Yeah, so there are two
There are
questions.
two groups.
Oh, this one here.
The 400 and 200.
The
150
400 and
100.
200. This was actually just to confuse the enemy. Yeah, this question was just there to confuse the enemy. So the questions, they will not be straightforward. They will make you think. Because when you look at this table, they have written chloroform exposed. Then you have liver cirrhosis, the cases. They put 400 and 200. For what? These are same people. So just have to add them. And also the controls, 50 and 100. These are same people. So just have to add them. That's why I said, first, before you go any further, you have to make a 2 by 2 table, which will make your work easier.
Sir, what is meant by the controls?
The control.
Yes.
So this is a case study or a case control study. So what is a case control study? What is a case control study?
This is a study where you are going to use the drugs on the other group. The other group will not be exposed to the drugs because you are trying to see the effectiveness of the drug on this other group.
Yes. So you have people who are exposed and people who are not what? Who are not exposed. Okay. So now, this mostly we do the case control study when you have maybe a disease which is there and you want to see the risk factor. What was the exposure? Were people exposed to a certain risk factor? Okay. So you get people who are sick and people who are not sick. Okay? People who are sick and people who are not sick. Then you compare their exposure to the risk factor. So for instance, we have this they say a case control study was conducted by the way of review to measure the association of river cirrhosis to a history of chloroform medication. So here, the condition, the disease was what? Was river cirrhosis. There are some people who had river cirrhosis. Then the clinician or the people who are conducting this research, they reviewed, file review. They reviewed some files to see if people had a history of chloroform what? Medication. Okay, so they are testing if there was an association between chloroform medication and liver cirrhosis. So we got people who were exposed to liver to chloroform, and those people who were not what? Exposed. Then we got people who have the condition and people who do not have what? Condition. Okay, so those are the cases and control. So the control are the people without the disease. Then the cases are people with the disease. Then we compare among those people who were exposed, how many people had the condition. So find that 600 people had the what? Had the condition among those who were what? Exposed. Then these people, the control, 150 and 100, they were also what? Exposed to chloroform. But they did not develop what? The condition. You have seen that?
Yes, I've seen.
Yeah, so
now,
these,
how can we explain
so these
the
were
lower,
exposed.
what the
The what?
table, the other narration for no chloroform exposure?
Yeah, so these people were not exposed. Okay? Among people who were sick, these 150 were not what? Were not exposed to chloroform, but they had the disease.
Okay.
Okay? Then these 300, they never had the disease and they were also not what? Not exposed. So if you check the pattern very well, you will see that among people who were not exposed, very few people had the disease and the majority did not have the disease. But when you look at those who were exposed, majority had the what? Had the disease, and very few people never had the disease. So now the odd, which is the likelihood, is a measure of the probability or the chances of the person developing the condition if they are exposed to a risk factor. Okay? The chances of developing the disease if the person is exposed to the risk factor.
Noted, I've understood. Thank you.
You are welcome. Yeah, so that is the gist here. Any further questions?
So, sir, this calculation, what is it? Is it the odds ratio? What is it that we are calculating? Or what is it that we are finding?
These are the odds.
really the odds ratio.
Not the odd ratio. So let me do this. I think we can have the opportunity to compare the odd ratio and the odds. Okay.
Sir, so this same odds, is it the final answer? Is it calculated in percentage or what? Or just in the absolute number?
Just like that. It just
The absolute
calculated just
number?
like that. The odds, yes.
Okay.
The odd you calculate just like the way you have calculated them. That is the odd. I'm trying to see if there's some points here.
So no measurements of whatsoever. So just four like that.
Yes. So that
Even the
means
0.5 like that.
So that means that is the odd now. The odds of developing the disease among those people who are exposed is 4 times compared to the people who are not exposed. Okay. Yeah. So we are here on the odd. Just a minute. So there is odd ratio and the what? And the odds. You need to know the difference. Okay. So this is the formula for the odd ratio. Let me start from above there. So the odd ratio. So the odd ratio is simply a ratio of the probability that an event will occur versus the probability that the event will not occur, or the probability, which is the probability over 1 minus probability. The probability that the event will occur and the probability that the event will not occur. So that's the odd ratio. So odd ratio therefore are simply a ratio of odds in general. They refer to the ratio of odds of an event occurring in the exposed group versus the unexposed group. Okay, so the odd ratio, if you are calculating the odd ratio, then you are comparing the events, the probability of events occurring in the exposed group versus an exposed group. So for example, you have this group might be men and women, an experiment group or a control group. So you can have an experiment group are those people who are exposed, just like what the madam was explaining. Those people who are exposed to a condition, or maybe those people who will give the medication, and the people who you don't give the what? The medication. Those are the experimental and control group. Then you compare the odds. Okay? Then the odd is going to be given by this formula, which is the probability of event to occur divided by the probability of event not to occur in the control group and in the ratio group. So now what we have here is odd ratio. If we have an odd ratio of 1, it indicates that the event is equally likely to occur in both groups. If when you calculate the odd ratio, you find the answer is 1, that shows that the event is likely to occur in both groups. Okay? Then if you find the answer is greater than 1, the odd ratio is greater than 1, it indicates that the condition or event is more likely to occur in the group, okay, in the first group. So for those people, maybe the one who are exposed and people who are not exposed. So if you find the odd ratio to be greater than 1, that means the condition is more likely to occur in the first group, the people who are exposed. Okay, then when the condition is less than 1, when the odd ratio is less than 1, this indicates that the condition or event is less likely to occur in the first group. Okay, so we have an example here. They say, suppose that in a sample of 100 men, 90 drank wine in the previous week, while in a sample of 100 women, only 20 drank wine in the same period. Okay, then the odds of man drinking wine are 9 to what? 9 to 10. Okay, then the odds of a woman drinking wine are only 10, 20 to what? To 80, or 1 to 4, which is 0.25 to 1. Okay, so this is now, these are the odds in this group. So this is what we are calculating: 90 to 10 for men and 20 to 80 for women. So, or maybe to make it easier for this one, we can construct a table like the one we had that side. So we have you construct a 2 by 2 table. So this side we have men, and then you have women. Okay, so the total number for men is how many? 100. Then those who drank wine are the cases. Those who do not drink are the what? Are the control in this case. So the cases for men who drank wine, how many cases do we have? 90. Yeah. Then how many control? 10. Yes. Then among women, how many cases do we have?
100.
The cases.
100.
Yeah, we have 100 the total. Then the cases? 20. Then the control? 8. Okay. So the odd, that is the likelihood. So when you see the word likelihood, like the one we have seen in our question, it means the what? It means the odds. The word likelihood is same as the odds. So the odds for men for drinking, we say odds cases divided by what? Control. So cases is what? Is 90.
90.
Yes. Over what? Over 10. So those are the odds, which is 90 to 10. So they just simplified this one. Then for women, the odds is what? 20 to what? Over 80. So these are odds. These are not odd ratio. Okay? Then now they say, if you want to calculate the odd ratio now, this is the odd ratio. Okay? This is how you calculate the odd ratio. So the odd ratio is going to be this one, 90 over 10. So they have just put it in decimal places. So 90 over 10, that is 0.9 divided by 10, the one that we have here, over 0.2, which is these they have just changed them to the decimal places, divided by 0.8. Okay. Then we can do the mathematics. Zero 0.9, or maybe let's just do it direct. We see if you get same answer. We can say 9.90 divided by 10. That is 9. Then 20 divided by what? 80. That is 0.25. Yeah, so what I was saying, if you want, you can do it direct. It will give you the same answer. The odds ratio, it will be the odds in the exposed divided by the odds in non-exposed group. So the odds in the exposed, for this case, we are treating men as exposed, right? Which is 90 divided by what? 10. Then we divide by the odd in the non-exposed, which is 20 divided by what? 80. What is the answer? This should be a division here. What is the answer here? So 90 divided by 10, that is 9, right?
Yes.
Yeah, then we divide by this 20 divided by 80, that is 0. What?
25.
25. Then 9 divided by 0.25,
36.
36. So that is this 36, which is here. So this simply means that men are 36 times likely to drink than what? Than women. So this is the odd ratio now. We have calculated. Okay, so I said men are 36 times likely to drink than women. Or the chances for men to drink is 36 compared to women. So they are more likely to drink. In short, men are more likely to drink than women. Okay. Yeah, so when we come to this example, so this is what we have calculated here. These are the odds. But if they say the odd ratio, that question now changes. So the odd ratio is denoted as RE is equal to odds in the exposed group divided by what? Odds in a non-exposed group. Okay? Are we together?
No.
We said there are two things. There's when this word, what is the likelihood of developing liver cirrhosis if a patient was exposed? So this question, to solve it, we just say odds is equal to cases divided by what?
Controls.
Controls. Yes. So that is the 600 you have put here divided by 150, which gave us 4. So this is the odd in the what? In the exposed group. Then the other question says, what is the likelihood of developing liver cirrhosis if a patient was not exposed? So it's also cases divided by control. So this one is 1, okay, 150 divided by 300, which is 0.5. We are done solving this question. But if they bring another question, maybe they say question B, they say calculate the odd ratio. Okay? So now the odd ratio is given by this formula. Odd ratio is equal to odds in the exposed group divided by odds in non-exposed. Okay? So what is the odd in the exposed group?
4.
4. Then what is the odds in non-exposed group?
0.5.
0.5. So 4 divided by 0.5. What is the answer?
8.
8. Yes. So this 8 means that those people who were exposed to chloroform, they are 8 times likely to develop the what? The condition than people who are not exposed. Okay? I don't know if that is clear. So,
Oh, sir,
yeah.
when we are calculating the the odds ratio, we are just concentrating on the group that was exposed. We
The
are
odd,
concentrating on finding is it the probability of I don't know. What are we looking for when we are using the odds ratio?
odd ratio. Yeah, we are looking
Yes.
we are looking at the probability of developing the disease in exposed group compared to non-exposed group.
Then when we are calculating the likelihood,
That the likelihood is the odd now.
okay, it's just the odd.
Yeah, the odd,
Okay.
which is cases divided by control. Okay? Cases divided by
Go through
control.
again the odd ratio calculation. Maybe I'll understand this one.
Okay, go through the odd ratio calculations again. So we have this question. The odd ratio is given as the odd.
I'm not seeing your screen.
You're not seeing my screen. Oh, maybe it's network. What about now? Or maybe who have understood, I want someone to explain. I want someone to explain this one so that we can help our sister to understand well. Madam Zodwa?
Let me try.
Okay, yes.
Yeah, you say that, sir.
You joined late?
Sorry, I was saying I'm doing late. Yes, I joined late.
Oh, true,
Even
but
10 minutes. So I'm very much behind.
okay.
Let me try. You say that when we are calculating the odds ratio, we are trying to look at the probability between the exposed and the non-exposed of being of having the disease. Yes, that's what I called. Now we are trying to look at the probability of between those who were exposed and those who were not exposed of having the disease.
Okay. Wonderful. So this topic we need to understand it very well. Yeah, like she has explained, we need to understand it very well. When we are looking at the odds, I'll give you an example. If yeah, let me say, I'm sure we are all health workers, right? So we are comfortable with any language. Okay? A person, if a person is playing around, right? Is involved in sexual intercourse without using a condom with multiple partners, and one person is not involved in any intercourse, is abstaining, okay? Who have the chances of having HIV?
The one who is having sex without using protection.
Yes, what about this person who is not having sex? What are the chances of having HIV?
They are very slim.
They are very slim, almost zero, right? Unless other circumstances.
Yeah.
That's why some people don't even waste time to go and do test for HIV. Because where can you get it if you are not involved in any sexual intercourse? You are not a health worker, you are not treating people who may have the disease. The chances there, if there are no other factors, we just say, okay, let's hold other factors constant, like you are not exposed to other factors, the chance of you having the disease is zero because you are not exposed to any factor. But this guy who is having sex, unprotected sex, the chances are very what? Are very high. Okay? So when you look at these guys, you find that maybe the chances is going to be the other guy, the chance will be zero. The other one, maybe the chance will be, like we have found here, the chance will be 4. Okay, for this guy who is exposed, the chances are very high. This one is 0, the other one is high. Okay, so this same concept is the one that we are applying here. There are these people who were exposed to what? To chloroform, and people who are not exposed to chloroform. So we want to look at what are the chances of having liver cirrhosis if we are exposed to chloroform. So the likelihood is simply mean the odds. What are the odds? So the odds in the people who are exposed alone is given by number of cases divided by what? The control, which gives us 4. That is the odd. That is the likelihood of you having the disease if you are exposed. Then, what is the likelihood of developing liver cirrhosis if a patient was not exposed? So that is the cases for people who are not exposed divided by the control for the same people who are not exposed. That is 150 divided by 30. So now when you are done with this, you want to find the odd ratio. The odd ratio is the number of or the chances of developing the disease if you are exposed compared to the chances of developing the disease if you are not exposed. So the formula is odds in the exposed group divided by odds in non-exposed group. That is the odd ratio. So it's going to give us, in this case, the odd in the exposed group is 4 divided by the odds in what? In non-exposed group, which is what? Which is 0.5. So we have calculated this and it has given us what? 8. So this simply means the people who are exposed are more likely by 8 times. Okay?
Hello, sir.
Yellow.
Sorry to interrupt. Before you go far, where is the 4 coming from?
What is the odd in people who are not exposed?
Oh.
Is 4. That's where the 4 is coming from.
She joined late. She wasn't there when you were calculating the
Oh, she wasn't there. So we said.
And then, sir, I wanted to ask, is this formula the same as that one you had initially given us, the one for P1 over 1 minus P1?
P
divided by P2 over 1 minus 2, P2.
P1, I have given.
The formula for odds ratio, is it the same as this one?
In the notes.
Yes.
Yes, it's the same.
It's the same.
Yeah, it's just that we have now summarized, but it is the same. This one.
Yes.
Yeah, it is the same. But if you don't want to get lost, you just have to use this. These are odds in the exposed divided by odds in the non-exposed. Now here they are using probability. Yeah, so that's saying you need to go direct to the formula where you are using probability. So it is the same, which is same as to this one. The one we have used here. Okay.
So in short, sir, the odds ratio is simply getting the odds. You divide the exposed over the non-exposed.
Yes.
Then you'll be able to get the odds ratio.
Yes, exactly. So you simply get the odds divided by the exposed over non-exposed odds. Then you get the odd ratio. You are done.
Okay, sir.
Yes. Okay. Yeah, so I'll share this one. You can go through again over and over. Then we have what is this question? Yeah, we have this other question here. I think we did this question before. We can just repeat it so that we can know the difference between the odds and the risk. Okay, so we have this worked example. There is a question which says, actually this was also a question from the past paper. So we have this data which is given here. This, I don't know if I can see the question. So this is where I was getting this question, just that here they are not so clear. I think this is the question. Okay, it wasn't even there on top, it was cut. But this is the question. So the first question say, compute the probability of suffering from acute chest infection in each socioeconomic group. So we have these socioeconomic groups. We have the socioeconomic status, where we have low, middle, and high socioeconomic status. Then we have number of adults, and we have adults with symptoms, which are the cases. Okay? Then the first question says, compute the probability of suffering from acute chest infection in each socioeconomic group, assuming that the number are large enough to satisfy the frequency definition of probability. Then question 2, calculate the odds of experiencing acute chest infection for both the middle and the lower socioeconomic classes relative to the high economic class. Okay, so this is the question. So what is the difference between the first and second question? What is the difference between the first and second question?
In the second question, there is no control group.
There is no control group.
Number of adults with symptoms. Because there we saw the ones that had the cirrhosis, then there was a control group.
So I've seen how the questions are coming. The questions are not straightforward, huh? Yeah, the questions are not straightforward. So this question, when you look at the number of adults and this with the symptoms, this means that this is a total. So there are some adults without what? Without symptoms.
Yes.
I've seen, huh? They are adults without symptoms. Those are the control group. So you can reconstruct a table in such a way, but yeah, we have seen that the questions are not coming straightforward. So you should expect that questions. Yeah. Then when you look at the first question on here, number 1, it says compute the probability of suffering from acute infection in each social economic group, assuming that the number are large enough to satisfy the frequency definition of probability. Okay, so this question, this is the first question that we want to look at. So when they say the probability, we have seen here they have used the word probability. Okay, then in another example we looked, they use the word what? Likelihood. What is the difference between probability and likelihood? So likelihood is the odd. Probability is the risk.
Odd ratio.
Likelihood is the odd. You are calculating the odds of developing the disease if you are exposed compared when you are not exposed, right? Then the probability, when you find the word probability, I just want to get you to get this word. The word probability means what? Risk. So odds and risk are different. Okay? So when you are calculating the odds is the number of cases divided by number of control. But when we are calculating the probability or the risk, the formula is this one. Number of symptoms or number of cases divided by the total population. Okay? Divide by the total population. That is the difference. So when they say calculate the probability of suffering from acute chest infection in each socioeconomic group, we need to calculate for each group, we need to calculate the risk of having infection. So we say the risk is given by what? Cases divided by what? Total, right?
Total.
Yeah.
Total.
Cases divided by total in that group. Okay. So in each group, we need to calculate the risk. So in the first group, the low socioeconomic status people. What are the cases? What is how many cases do we have?
31.
31, yeah? So 31 divided by, what is the total population in this group?
79.
79, yes. Okay. So that will give us what? 31 times 79 divided by 79.
0.39.
0.39. 0.39. Yeah, so this is the risk in this group. Then in the mid economic class, mid social economic class,
0.22.
yeah, the cases is 28 divided by what? 120.
Middle.
Yeah, middle.
Middle is 28.
Yeah, 28 divided by
122.
122. Then in the high is 23 divided by what?
23 divided by 197.
Yeah, 197. So this is how we calculate the risk or the probability. So these are the probability. This is how we calculate them. Okay? Which can be converted into percentages. So if you are coming from the raw economic class, the probability is 31 divided by 79, which is 0.32, 0.392, which is 39.2%. So that is the risk of you having the disease. Then mid economic class, we find 23%, and the high economic class, 22 divided by 1.7. Then when we go to this other question, which says now calculate the what? Calculate the odds of experiencing acute chest infection for both the middle and the low socioeconomic class relative to the high classes. What does this question mean? What are we calculating here?
We are to get those that are exposed and those that are not exposed.
Those that are exposed.
The odds.
Yeah. So we are comparing they said calculate the odds of experiencing chest infection for